Can you think about the last time you took antibiotics? What could have happened if you didn't take them? Many people's lives depend on their use and effectiveness. However, they are also affecting our environment and posing serious damage to our public health. Hi, my name is Silvana, and I want to share with you my doctoral thesis on removing antibiotics with biological wastewater treatment. I'm an early researcher at the Department of Chemical Engineering of Crectus Research Center of the University of Santiago de Compostela. My work is part of a joint doctorate program between USC and RWTH Aachen University, funded by Marie Curie Actions through the project NOWELTIES. Since their discovery, antibiotics were called miracle drugs, and they are one of the most powerful discoveries of medical history. They allow us to improve our life expectancy and quality of life. The use of antibiotics allows us to kill infectious bacteria, and we benefit from it. Every time each one of us takes an antibiotic, most of it gets excreted from our bodies. The same happens with animals. In a developed world, most of our poops and urine is collected by sewers to wastewater treatment plants. Therefore, many antibiotics residues from households, hospitals, animal production, and pharmaceutical industries gets discharged on wastewater treatment plants. The problem is that existing treatment plants are not removing antibiotics completely. Thus, these chemicals are spreading to the environment. It is precisely the ubiquity and the persistence of antibiotics in the environment that becomes a problem. Exposure to antibiotics puts a stress on bacteria, and they defend themselves by sharing genes that allow them to survive, and they create their resistance. This is antibiotic resistance. As we use ever more strong and diverse antibiotics, new and more powerful bacteria ever evolve, such as the so-called superbugs, for which antibiotics do not have any impact anymore. In a world with antibiotic resistance, a common infectious disease can kill us in a glimpse. But then, are bacteria friend or foe? Luckily, bacteria also can break down antibiotics. We call this biotransformation. We as engineers can use bacteria to remove these chemicals from our wastewater treatment plants. But first, we need to understand exactly how this happens and which factors we can twitch to our advantage. Enhanced antibiotic biotransformation has been documented during biological nitrogen removal, where certain types of specialized bacteria produce enzymes that help neutralize antibiotics. However, our current understanding of biotransformation at the level of enzyme-chemical interactions is limited. During my PhD thesis, I'm studying different types of bacteria and their capacity to biotransform antibiotics. This can provide knowledge for its technological application on existing treatment plants and improve their effectiveness. If we want to avoid antibiotic resistance, it is critical to have a more responsible use of antibiotics. However, it is not enough. We also need to work towards providing a safer sanitation and improved water quality on a global scale. The NOWELTIES project is a European consortium of top scientific groups working towards the development of innovative technologies that can control this type of emerging contaminants, such as antibiotics. If you are interested in knowing more about these innovative technologies, you can contact me or visit our website at novelties.eu.